Hi, I got a couple emails saying you wanted to see some problems. So here's some problems from the worksheet. Let's start with number 2. I did problems 1 and 3 in class, I think, but here's number 2. We'll start there. It says, what's the final temperature? That's this one of the water when 0.5 kilojoules, which should be in joules, that's 500 joules, that's the Q, are added to 135.8 grams, there's your mass, of water at 14.8 degrees Celsius. There's your initial temperature. The specific heat of water, which you need on a couple of these problems, is right there at 4.18 joules per gram times Kelvin. So if you're going to solve this problem, start plugging numbers in. The Q in this problem is 500 kilojoules, which we know is 500 joules. Sorry, I said 500 kilojoules. It's 0.5 kilojoules. 500 joules. So that equals to the M, the mass of the water, is 135.8 grams. Specific heat of water, told to in the problem, 4.18 joules per gram times Kelvin. And then finally, here's where things get tricky. You're given the initial temperature, but you don't have the final temperature. So the initial temperature is 14.8 degrees Celsius. You want to get final temperature by itself. So the first thing you're going to do is divide both sides by 135.8 and 4.18. So you take 135.8 and 4.18. You divide so they cancel out. I'm going to write that over here because I'm just running out of space. So 500 joules divided by 135.8 times 4.18 on bottom here. And then these cancel out. So I'm doing that over here too. I'm just not writing it. So that is equal to final temp minus 14.8. And if you want to get final temp by itself, the next thing you do is add 14.8 to both sides. So one more rewrite for the MEMS of 500 joules over 135.8 times 4.18. Do that on bottom maybe. And then I'm going to add 14.8 to my temperature to get the answer. And so the answer, I think, ends up being about 15.7 degrees Celsius for your answer if you rearrange and solve it that way. So that's number 2. Let's see what else is there. I could do number 5 too. What's the specific heat of a substance that absorbs 2.5 times 3 to the joules of heat? That's your Q. When solving for C, by the way, what's the specific heat? It's a big sample, 10,000 grams. So that is your mass, and it increases from 238 to 343 K. So there's your initial temp. Here is your, there's your final temp here, there. So plug them in. I'm solving for specific heat. I've got, actually, I would probably rearrange first. You don't have to. You can solve it any way you want. But for me, if I was going to go with this, Q equals MC delta T, and I want to solve for C, I'm going to divide both sides by M and delta T. So you're going to get something like this. That's not a very good delta. That's even worse, but whatever. And then M and delta T, of course, these cancel out, and you'd have C by itself. So setting up Q over M times delta T equals C, which is what we're solving for. So I'm going to do that over here on the left-hand side. Just going to plug everything in. The Q is the joules. Excuse me, it's 2.5 times 10 to the third. And then I'm going to divide it by, let's see, the mass is 1 times 10 to the fourth grams. The delta T is 343 minus 283. Gotta do that first, of course, if you want to get the right answer here. And if you do all that, you're going to get super small specific heat. It ends up being 0.0042 joules per gram times Kelvin for your answer. So there's a setup for number 5 on that front side. Maybe one more for the MEMS. Last problem. I'll do number 1 on the side here. How much heat? Heat is Q in the specific heat equation. By the way, it was in the notes, but it's also right here. I wrote it on the top here. So if you need a thing to write down, it's a good thing to have so you know what's going on. So how much heat must be absorbed. So I'm just solving for Q. This is the mass, grams of water, to raise the temperature by 25 degrees Celsius. So I'm not given an initial and a final, I'm just given a change. So they've already done the subtraction part for me. So in this case, delta T is actually just equal to 25 degrees Celsius. So there's no change, because they're just telling you the change is 25 degrees Celsius, right? It says raise it by that. Okay, so you just plug in. I've got, it's water, by the way, so the specific heat of water right there in black, 4.18 joules per gram times Kelvin. So solve for Q equals mc delta T. Plug your numbers in. The mass is 375. The specific heat of water is 4.18 joules per gram times Kelvin. And the delta T is, as they told you, 25 in this problem, 25 degrees Celsius. So you plug all those numbers in there, and you get a really large, well, it's not, you get a large number, but it's not a very large energy. It's 39,187.5. You want to probably, you could also convert it to kilojoules if you want to, just multiply by, or divide by 1,000. So you would have, what's that, 39.19 kilojoules if you are into writing things as kilojoules. So there's a handful of problems from the specific heat worksheet that hopefully clears some things up for you and allows you to do the rest of them. Okay, bye.